There's not much that can be said about logarithms that someone else hasn't said better already. But I recently had a conversation with someone about the change of base formula. The question came up, why is the change of base formula what it is? This wasn't a question of how does the thing work, or of how do I use it. No, this was a bit different. So I'd like to take a moment and look at the logarithm change of base formula from a geometric perspective. I'm going to use an idea from Vi Hart's video on logarithms, linked in the description, to talk about this. It's not necessary for you to have seen the video, but it's a much richer exploration than I'll be giving. Question 1. What's a logarithm? Answer. We can think of logarithms as the number of steps it takes to get from 1 to a number, when each step means multiply by a thing if we go forward, or divide by that thing if we go backward. Example. If our logarithm is based on multiplying by 2, then it takes 8 steps to get from 1 to 256, because 1 times 2 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 is 256. So the logarithm of 256 is 8 when we use 2 for our base. Question 2. What's the change of base? Answer. The change of base formula helps us use one logarithm to talk about how another logarithm works. It looks like log base b of x equals log base a of x divided by log base a of b. And sure, we could do algebra on this thing and see that it does work, for sure. But that's not really what we're trying to accomplish today. Question 3. So, why is that thing the change of base formula? Setup. Each of the logarithms in that change of base formula represents something. Using our steps analogy from question 1, we can draw a fairly straightforward representation of each. Log base a of x is the number of steps it takes to get from 1 to x if we multiply by a. Log base b of x is the number of steps it would take if we multiply by b instead. And log base a of b is the number of steps it takes to get from 1 to b if we multiply by a. Answer. If we compare the steps of log base a of x to the steps of log base a of b, every time we reach this many steps of times a, we can replace it with one step of times b. We can think of this process as creating groups of times a. But creating groups of is just another way to say dividing. So the comparison step is just taking the log base a of x and dividing by the log base a of b. Now, as we collect these groups, we notice that we are 1. Going to reach exactly the same height, meaning we'll end up at x, and 2. Our new count is going to be steps of times b. But this means that the regrouping step gives us exactly the logarithm of x where we use the base b. That is why the change of base formula is what it is.